Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you are new here, you can check out the previous videos to follow along. In today's video, we will work on container with most water. So the problem states that we are given an array height where each element represents the height of each vertical line. We need to pick two lines such that together with x-axis it forms a container that can store maximum amount of water, and the area for this is calculated by width and height. Width is nothing but the distance between the two indices, and height is nothing but the minimum of these two heights. So the key observation is, even if one line is very tall, we would be considering the minimum height because the water level is limited to the shorter line. For example, if we consider these two red lines, even though this line is of height 8, we are considering height 7 because the water level is limited to the shorter height. Now for the brute force approach, we would be trying all the possible pairs like always, and for each pair we would be calculating the width, we would be calculating the minimum height, and then we would be computing the area. Then we would be updating the maximum area for each pair. So for that, we need to initialize a variable called maximum area to keep track of the maximum area calculated so far, and n would be the length of the given array. Let's iterate from 0 to till the end. And for the second loop, we would be iterating from I plus 1 because we are not considering two same indices, j less than n, j plus plus. And now we need to calculate width, height and area. For that, width is nothing but the difference between two indices. Current height is nothing but minimum of the two indices. And the current area would be width into height, the current height. And we also need to keep track of the maximum area in every iteration. So the maximum area would be math.max of max area and the current area. At the end, we would be returning the max area. Let's run the code. Okay, this code works, but like always, this is not optimal for larger inputs because here we are using two for loops starting from 0 till the end, and this also is iterating through almost every element. So this leads us to a time complexity of O of n square, and since we did not use any extra space, the space complexity would be linear, which is O of 1. Now let's understand why this brute force is inefficient. So here we are checking for every combination. So let's consider the first iteration. The first loop would start from here, and in the second loop would be iterating and checking the maximum area for all these future lengths. So to reduce that, the key idea here is we need to maximize the area. So we need large width and minimum height. And now this leads us to two two-pointer approach. We can use two pointers wherein one pointer is at the start and other pointer is at the end, start and end. Uh, and at every step we'll be calculating the area using these two lines. So the important rule is that if the left height is smaller, we would be moving the left pointer forward. If the right height is smaller, we would be moving the right pointer backward, because moving the taller line will never increase the area, so we would be moving from the smaller line. So the code for this goes like, we need this, okay, we need two pointers, left which starts from 0 and right which starts from the end of the array, which is nothing but height dot length minus 1, while left is less than right. We would be iterating till the two pointers meet. While left is less than right, width is nothing but the difference between right and left, and current height is nothing but the minimum of these two heights, and the current area would be the product of these two, width into current height. And we need to update the maximum area in each iteration. It would be math of max area and the current area. Now if the left pointer is smaller, we need to move away from the left pointer. For that, if height of left pointer is less than height of right pointer, then we would be incrementing the left pointer, otherwise we would be decrementing the right pointer. And when these two left and right pointers meet, our while loop would stop executing, and at the end we would return max area. Let's run the code. It is working. Now let's submit it. It is accepted. So the time complexity here is improved from O of n square to O of n, because now we are calculating it in a single pass, and the space complexity would be O of 1 because we did not use any extra space. Now coming to the edge cases, this works for duplicate heights, and this also works when the height is 0, and we will always be using two different indices, because we are starting from the first, and we are the left pointer is starting from the first and the right pointer is starting from the last, and this would be decrementing and this would be incrementing. Whenever they meet, this while loop would terminate. So there is no chance that we are calculating for the same vertical line. Let's take an example and dry run. If we consider this, the height of this is 9, and if this is 0, this would be 8. While left is less than right, while 0 is less than 8, width would be 8 minus 0, which is 8. Minimum of two heights is this one, so the current height would be 1. So the minimum, this is nothing but the minimum of 1 and 7, which is 1, and the current area would be 1 into 8, which is 8, and the maximum area would be the max of 0 and 8, which is 8. Now the left pointer is less, which is 1 is less than 7. That's why we would increment the left pointer from 0 to 1. And the right pointer stays as is. And again in the next iteration, we would start comparing from 8 and 7. The width is nothing but right minus left, which is these are nothing but the indices. 8 minus 1, which is 7. Height would be the minimum of these two heights, which is 7, and area would be 49, 7 into 7, and maximum area would be 49, because max of 8 and 49 is 49. And now, since this is smaller, we would be decrementing the right pointer now to 7. Now again the width would 1 is less than 7, true, and again difference between 7 and 1 is 6, and the heights minimum of left is at 1, okay, minimum of 8, and this one this is 3, 8 and 3 is 3. So the area would be 18, the max area would be the same. And now since this is smaller, we would reduce. And likewise, all of them are smaller, so there is no chance for the area to become more. So you can write on the code. The maximum area would be would remain 49, because all other heights are smaller than these. So the height would be 49, which we already got, and that would not be changed because all the heights are smaller. So that's it for today's problem. In the next video, we'll be solving trapping rainwater, and we'll be continuing with the same pattern. Thank you.